So we have the fourth lecture here. As you know, as I already mentioned today, we are going to deal not just with the programming perspective, but with also the analysis and design perspective. Often we just simply, when we have some task to solve or to support something, we just sit and program and do not use any additional graphical notations or whatsoever, or simply because we know how to deal with things. We actually know what we need to achieve, and we do not need to discuss this with others. But in case of extensive projects, extensive problems, extensive systems, we often need to communicate decisions and possibilities. I'm asked to turn these shades the other way around, because it actually shines.
Okay.
Yeah.
Even these?
Yeah. Thanks. So the thing is that occasionally, and this is not the moment that I'm going to convince you that modeling might be useful, but you know that models, graphical models in particular, are being used. So actually, we touched this a little bit through use cases, which also have their graphical version in UML, although they are mainly actually text. So now we are going towards this more extensive graphical modeling, expressing the system graphically. So in this sense, now let's start with some kind of example. So in small applications, small systems, usually we do not write down requirements, but sometimes when the problem is bigger and we need to understand what is or to know exactly what we need to implement, we must collect requirements in one way or another. Use cases might be a way to collect requirements as well, directly, but sometimes we just write down the statements that we collect from the client. And it might look like this. It might be numbered, it might be better organized or whatsoever. There might be hundreds, thousands of requirements, but let's have a look at this small part of a specification of some security system. So we have, and how can we come to a solution, presumably in an abstract-oriented way. So here we have typical requirements, like each alarm bears its ID and the indication whether it is connected to a special sensor. Then we have when the security system is being shut down, all its sensors are being turned off. And sometime later in the specification there comes some a little bit maybe different requirement. Alarms placed in buildings and connected to special sensors are excluded from being turned off during the shutdown of the whole security system. I already indicated that, or revealed that this requirement, and it's a little bit longer, but that it's a kind of a little bit different than these two. Maybe I shouldn't have done that. But I said that. So now I'm going to ask you, why? Do you think this requirement is different than these two? Really? Do you agree with me? and in what it is different. What makes it different?
It's very specific.
Very specific. What?
It uses pointer to another requirement.
Mm-hmm. Refers to other requirements.
Yes,
Yeah, refers to other requirements. These two seem to be kind of, well, there are somewhere in the beginning, so they don't have very much other requirements to refer to. If they wouldn't refer to further requirements in the specification, which is also possible. But here, that clearly requirement 3 and 4 seem to be kind of self-contained, more or less, standalone. And this one seems to be a little bit dependent on previous requirements. Nevertheless, our first approach, if we would have a huge specification and if we would want to present it in a graphical manner, we might come up with some kind of a network like this. Here are maybe some other requirements attached to these notions that we identified, or we might say themes or topics, themes that resonate throughout the specification. So we identified the keywords, the important things. We don't know yet what they are going to be, so we are pretending that we are kind of we simply don't know the way the system will be implemented. Maybe it will be implemented in a procedural manner, maybe in an object-oriented manner, maybe in one language, in another language, who knows. So for now we are trying to understand what's there and how things are related. And actually this could be generated automatically. So this, I'm not saying that I'm recommending this way, but or automatically generating this network of requirements and themes around which these requirements occur. But it might be done so. So what we see here, that some requirements are connected, like that we had R3 and R4 that were kind of standalone requirements, are connected to only one topic or theme. So we don't see the whole text here. I actually expanded only one requirement, and that's requirement R8, which is in a somewhat special position, that we felt that it would be in a special position with respect to these other requirements. It is actually kind of an interconnected requirement. Connects several, we might say interconnect several requirements, but actually if we extract from requirements or from the requirements the themes, their subject, what they are about, the key things they are about, then we actually can relate this requirement to rather to those key things or issues than to the requirements themselves. So there are no connections, direct connections between two or more requirements, but everything is, all connections or whole relatedness is expressed via connections to those themes. Themes are expressed in these triangular shapes, and they are named in some way. Well, okay, it's all. It's not, maybe it's not an ideal way to express these themes, but our first approach to the problem. So we might refine these names further, or maybe they were generated like this because they were extracted by an automated tool, and once such a tool was actually built and proposed, and there are maybe other tools that are not related to a specific, particular to aspect-oriented software development that do the same thing, and this is related more or less to the larger area of natural language processing, but we are not going into this. So for now, we can see that we have this requirement which is in a special position with respect to other requirements, and it interconnects several themes. Thinking of how can we deal with this if we would implement such a system. So we are entering now the phase of analysis, looking at this diagram. We might make some decisions already with respect to how these are actually some kind of we feel that maybe these are some structural elements of our system already appearing. We are dealing only with the application domain, of course. So we are trying to fit the solution domain, which is when we think when we recall that we are in a course on aspect-oriented software development. So our solution domain will be an aspect-oriented programming language, presumably AspectJ, but whatever. So we will be dealing with this also with aspects. So having in mind this, we might ask ourselves how this requirement actually, or not requirement, but because requirement will vanish in our system when we implement it. There will be no requirements, but these themes will remain there or resonate through the structure. So these are maybe already, as I said, some structural elements. So looking at this, we might we assign actually some kind. We assign to these structural elements the responsibility for maintaining or implementing requirements. Okay, so these guys are responsible for. This one is responsible for R4, and this one is responsible for this, and also for it is affected by R8, but this exclude alarms is responsible for 3 requirements, and so on. And we might ask, once these requirements vanish, what relationships will be there between these themes? And one of the solutions that we might come to is that exclude alarms connected to special sensors would take responsibility for this requirement 8 and impose that requirement on other structural elements of our system that are affected by this requirement. So I will get back, so we can see that R8 is between or among all those 3 to be structure elements, not already structure elements, but themes that are becoming or expressing, exposing a bit the structure of our system to be. So we must decide which one will have the responsibility for this requirement 8, and for other requirements as well. So we might see that once we declare that R8 is on this theme, so this theme is responsible for R8, we actually impose its consequences to other themes, which is indicated by these arrows, and we actually our themes, our other themes remain connected only to one requirement. So we actually restructure that graph so that we identify clearly the arising or appearing elements of structure to the requirements that they will implement. And one of these requirements is quite special, so R8 needs to be imposed on other structural elements. And looking at this and recalling what you know about aspects for now, what does this remind you of? If you would have to decide which of these themes could be implemented as an aspect, in the sense that that you are currently most familiar with, this is the aspect J language.
So
yeah.
I would choose the theme that's independent, exclude alarms connected to special sensors. I would choose that theme.
That one to be an aspect.
To be as, yes.
An aspect. So actually these arrows, if we draw this a little bit differently, so exclude alarms connected to special sensors. If I would say that this is not a rectangular shape but an oval shape, so I would say this is exclude alarms. And if I draw these two like this, so this is shut down, and alarms, which does not. But if we get back a little bit, alarms, it's called alarms, but take these names as a first approximation, because our specification says each alarm bears its ID and the indication whether it's connected to a special sensor. So we might think of this theme alarms as a set up alarms or something like this. If we would like to indicate the action behind this thing, and if we draw these arrows like this, and if we add our client like this somewhere, maybe it's not the best position for our client, we would need to connect it to these, probably not to this one. I would rather connect it to this one because our client, or I don't know, system operator shuts down the system, and also he sets up the alarms. And this is something that happens more or less as a kind of automatically according to these two actions. So this is shut down the system, exclude alarms. So these sound and look like use cases, and this relationship looks like extend. So, as you know, we might set so the consequence, the implementation consequences of these use cases then are in terms of classes. So this one will be covered by at least by one class, alarm class. So this is what will produce or imply. This one might imply some functionality in a system manager class or whatever. Not the whole class, but some parts of it. And exclude alarms might, if we implement things in aspect-oriented sense, might be an aspect. But this approach and this kind of structuring, transitioning between these two views is a different way of dealing with aspects, but a similar way of dealing with aspects as we saw in use cases, and we'll get back to this a little bit in our next lecture as well. So, but we are not talking explicitly here about use cases. So this is kind of bypassing the use case thing, or if we deal with or have to deal with a specification document as an example of which I shown a few minutes ago. So this is something that we can arrive by an analysis, and then if we would like to further elaborate on these use cases and classes, we could do that, of course, in code, but we might do this in another part of this approach, which is called theme. So this is already a part of this, these are use cases. So theme approach, and actually it has two parts. It has, this one was so-called documentation, and we will deal now with its other part, which is called theme UML. So if you would like to elaborate graphically further these themes, we might use a UML-like notation, which I will show you an example of. So the question that should, maybe you should not ignore this question before we take a look at an example. But what do we need actually to express in the aspect design? So now we can see that there are some structure elements. We might guess that some classes are behind this. Do we need anything else? So one thing for sure that we need to express in the aspect design or in any design, when you design things in object-oriented way.
Class.
You need classes. Okay, classes.
And the relations.
Relations between classes.
And method names, like the ones you want to capture or modify. And
method names.
Or maybe generally attributes also.
Attributes. Attributes and anything else? I must not make mistake because there is no way on. Let's Anything else? What do you have else in your UML models typically? With respect to methods, are you satisfied with having just method names?
Also,
You don't need to know
some structure of packages.
structure of packages. Okay, packages. Well, that won't help us with what is a method? Can we?
Sequence of steps. Some sequence of steps.
Sequences of steps.
So,
Sequences of steps expressed in. Yeah.
Method calls.
Method calls. Method calls. Okay, this is something different, isn't it? Maybe I can draw a line here. We entered a different area. Behavior. And this is structure. Behavior is structure. So we need somehow to deal with both things. If we want to have a complete, not a complete model, but if we want to at least attempt to express a design that will bring us to code as much as it can, because here we will have some parts of the system, some method names. We might introduce some method names in our classes, but what they will do. So we need their implementation, how they will behave, and relations. These are relations between classes, but there are also relations between methods, by method calls, and in a way this affects the relations between classes. So if we deal with behaviors, we will come to some different or improved understanding of the structure, and maybe some other classes or some other parts of classes might come out of that, and vice versa. Once we are thinking of classes, we might identify what methods should be there to some extent, and then we will need to specify them further with sequences of steps, maybe using sequence diagrams. And here we will use mainly class diagrams, maybe package diagrams. Maybe we will use here activity diagrams and state diagrams as well. But most often we use sequence diagrams to show the order of calls, relations between methods. There might be some other things that we can express in sequence diagrams, in particular in the modern versions of current versions of UML. So, if we want to cover both things, we might use UML notation, but still, if we want to stick to our partitioning into themes, we might like to preserve this somehow in that UML that we will use to express structure and behavior. So for now, there is no behavior, much behavior there, but we have a structure, which is actually a package structure that we know already, but it is given a special meaning by using this stereotype theme, and we call it alarms, just as we named our theme in the analysis. So we maintain the links to analysis. We might like maybe to clear out that analysis a bit before we approach design, the design phase. Because some of the themes, as in particular if we identified those themes quickly going through the specification or by help of an automated tool, we might need to think about analysis before we decide to approach design, because then we will have a mess in design, and that will be much more difficult to deal with, since we will have much more details there involved. So no big deal with this theme. We don't need much more of behavior there, because there is nothing really interesting going on. We don't need to express, and as it goes, if we don't need a complete model, if we are not after an executable model, executable UML, there's a version of UML called executable UML. If we don't want this, but we want just this model to help us communicate the design and think about the design, then we don't need to express everything, but we need to express the most important, most difficult, most sophisticated things in our design. So now, we might take a look at another theme, which is shut down the system. How it goes, actually. We actually might like to start not with structure, but with behavior. And dig out the structure from the behavior. So we will probably draw this some version of this sequence diagram before we draw this class diagram, and we would find out the objects that we want to deal with, because we know maybe that you should know probably that maybe it would be expressed some other requirements as well, but might not be expressed anywhere. So we might need to go to implementation sites, to say so, to visit our client and see that their buildings actually contain rooms, and that their idea of having alarms is not limited to having alarms just on their buildings, just on the entrance or windows or so, but also within those buildings, between the doors that connect rooms and corridors and so on. The structure might be much more complicated, but for the sake of the simplicity, in this example that we are studying now, we are dealing only with buildings that contain rooms, and those rooms can contain alarms. Also, windows are actually a part of those rooms, so there is nothing particular connected just to a building, to say so. Although there might be some alarms connected to a building, but this diagram does not show that. We might have that as well. So when we are shutting down the system, we are actually shutting down alarms, and we need to go find our alarms by following. Then we are shutting down a building, so all the rooms there, and finally the alarms which are there. That's some kind of a loop. So I'm using here an abstraction of that loop. I'm not introducing any conditions there, but we understand approximately what needs to be followed, and how it would happen. So our models are not necessarily complete in all the details that we would need to introduce later in code. So once we have these two themes, we might need to compose them, to connect them, because actually this previous theme, last theme, the second one, actually refers to alarms, but it refers to alarms only with respect to the ability of being turned off. If we have a look at the alarm class introduced here, it's much more bigger, complex. There are other things covered by it. So here, for the sake of this theme, we deal only with the ability of being turned off. Although we know that this is the same class. Maybe turn off is not even introduced there, but it is. There might be two cases for maybe we would introduce turn off and turn on, but actually this is important from the perspective of alarms. So some methods might be repeated, some methods might be not repeated, but we are actually dealing with not with classes themselves. So these look like classes, but they are not complete classes. They are partial classes. And probably when you have drawn your diagrams in UML by hand, just to expose some part of the design, your classes were equally incomplete and partial, just like these classes. So observe that this is a natural attitude towards design. We want to show and when we need to show something like this, like all attributes, all the methods, the picture becomes cluttered with details, and we cannot see the main message. And recall your tools that you use to draw UML diagrams. How many of these tools, or can you recall any of these tools that enable you to deal with partial views of classes? Okay, I have my big model with hundreds of classes. I can pull 3, 4, 5 classes that I need to show in one diagram. But I cannot do usually, and I cannot myself recall any of those tools that would enable me to effectively hide individual attributes or methods. So I don't want to show here these 3 classes with all the details that they might have. I need to show only those that are needed from the perspective of this theme or specific point of view or aspect. And that's something that we might think of, and might be an interesting way to think of the design, which actually I'm not sure is very much present in any of the approaches that that are available currently, and has to do with aspect orientation. Has to do with essential things in aspect orientation, ability to show partial views of classes. So you might consider this if you would like to consider your project topics about something like this, about performing some kind of study or developing a small extension to some tool, or there are actually graphical there is a good graphical support for UML in clips that might be adapted somehow. So this is something to play with. But principally, or talking about this idea of theme UML, we already have this, not supported by a tool, but supported by as a developed notation, and it is well documented. It is documented in a book with all the details and peculiarities for this notation. So you see that the things will get complicated with this notation as well. But the most important thing is that we are dealing, that you should observe that we are dealing with partial views of classes there. There might be several sequence diagrams, several maybe activity diagrams, some state diagrams as well. We will deal with only with sequence diagrams like this, for the sake of simplicity. Now that we have this partial view, one and the other one, or several partial views, for the system to work, function properly, we need to compose them. Just like your aspects in your code. You need some kind of a so-called weaver that will weave together all these pieces so that your system will finally have complete full classes with all the methods and everything. You don't have to see this, but it needs to be represented somehow in the memory, so in order to be possible to execute this. Okay? We indicate that there are many ways to compose things. We indicate the most simple way or straightforward way, where we don't want to deal with, we might define separate rules for each element, each method, and whether one method bypasses the other one. So if we have two versions of the turn-off method, as we noticed, which one will be valid? Or one in the alarm class should come before that in the one introduced in the alarm class in the shutdown system theme. Who knows now? Yeah. So we need to decide and specify these specific composition rules if they are needed. Otherwise, we can rely on a simple way of composing themes. If everything is straightforward, that we compose, we build yet another big overall theme, to say so, which is called security system, and we match the elements by name. So they're actually, we can consider them equal, and one of them becomes, they are not repeated, so there will be no two turn-off methods. There will be only one turn-off method, and it will be adopted from one of the classes that offers it, because they are implemented. We consider them to be implemented equally. We if there is an alarm class in one package, in one theme, and in another, then we consider it to be the same. So their elements are composed. That's one way of dealing with things, but this class, this theme exclude alarms connected to special sensors, we felt that it's a little bit different. This theme actually imposes some things on other themes, and as such it defines something that needs to be somehow be composable in a way that it needs to affect the things in other themes. So we need to say to what themes this is related, and we need to define this cross-cutting behavior somehow, but we don't have structure. The structure will come from those or with those themes that are that we are actually composing our theme with. So what are we going to do here in order to be able to imagine the things? Because we don't have those. We don't have those themes. We are dealing just with this theme that is cross-cutting. We are going to mimic that structure, just in testing when we don't have all the structure that we need to have, or when we develop some prototype systems, we have some mock objects which are not really, which are just standing there for the sake of the completeness and help us define some things, but actually are just shells with no real behavior implemented inside. So here, the essence is that we have some when we exclude alarms connected to special sensors, we have some operation class, to say so, which actually we need to allow to be executed or not, or actually which we actually block from being executed according to some condition. If it is not fulfilled, that condition, then we let the operation being performed, otherwise not. So we need to some way to express that, or to have a look on how this operation that we are dealing with is being executed. Or so this is a sequence diagram of that operation, or the sequence diagram of that operation. So whenever that operation starts, it starts by being called, maybe that start state, which is being used also in as a symbol of a fact dot, being used in sequence diagrams, could be used there for the sake of completeness, but this notation, this theme UML notation came before UML was extended by this. That's called, so that would be our operation, found operation. So it came from somewhere, we don't know from where, we are not interested in exploring that. And we are exploring the body of that operation here. So this is the operation that is being performed. That is a part of the operation class, and it goes like this. Yeah. It goes like this. Actually, what it does is not very important to us. That would be actually drawn here, but it is important that it starts somehow, and then we can define. We are not defining actually that operation, but we are defining something about that operation. We are defining something about the operation that actually describes whether this operation is being let to be performed or not. So this is not our operation. This is just a call to our operation. Our operation is indicated by this special name. Underscore, do, underscore, and the name of the operation. So this is a part of this do is do underscore do is a part of theme UML and it stands for the real operation, the body of the operation. So we don't deal with the body of the operation here. We are dealing, because we are talking about that operation, not what is within that operation. We are not interested what is within that operation. Which operation it is, we will receive it through these parameters, or through this parameter here, and we will receive this operation condition, which is actually, we define this condition through this parameter there. So this is actually a parameterized package. Maybe you dealt to some extent or saw parameterized classes in UML? No? You do recall generics from in Java, yeah. Generics in Java. So this is something like that. So you supply some other types or whatever as parameters, and there's a generic structure that accepts these. So this is a a little bit a generalized way of generics, to say so, a different way of generics, but the principle is the same. So you supply some missing elements in your generic structure, which are in this case a specific operation, specific condition. Actually, by implicitly by that you supply this operation class there, and you define your behavior or whatever you can define in a generic way to be applied in many cases. So this is actually currently to some extent possible in UML, although this is used in a little bit in a different manner. There's a link to this lecture if you would like to check this out in the specification, UML specification. But theme UML came with this at the moment in which in which template classes and template packages were not known in UML, not used. So this was an extension that was invented in theme UML, not a part of regular UML. Well, this might be confusing like this. Maybe I should have shown you that this theme is then connected to the alarms theme, which actually supplies. So here we have this bind expression. This is a different expression than that one for composing those themes that are practically on equal level. So alarms and shut down the system, they are like not parameterized packages. They are just normal packages. They include partial views of the elements, different elements, and these are like put together. But this is different. This theme is a parameters theme, and actually affects this theme and affects the elements that we bind this theme to. So our operation would be the turn off operation, of course. This is the operation that we want to block at some points. We want to block it because we have this requirement. Alarms placed in buildings and connected to special sensors are excluded from being turned off during the shutdown of the whole security system. So we might have some alarms that are not placed in buildings, and we might have some alarms that are not some alarms are connected to special sensors, and some alarms are not connected to special sensors. This is indicated to some extent here. So special sensors, whether it is connected to a special sensor or not. So we know that, but we need to decide to actually filter this out, and we do this by this theme, which is defined in a much more general or generic way. But we bind these two operations, so the operation to be tracked and presumably in some cases blocked, and the condition testing operation has special sensor here. So these two things come from the alarm class, which is defined here, and we connect or put these elements into function there within this theme. So now we have two ways of dealing with aspects there. This one is, if you would make an aspect-oriented program, what would be this theme? If you could implement this in aspect J, this theme would be this exclude alarms connected to special sensors. An aspect. And the alarms theme would be just a simple class. Something like this, maybe you can have a look at the implementation. So the design is confusing enough, so we need to have a look at code. The code doesn't lie. We might draw any picture. It won't be executed unless it is an executable UML. So now when we program it, we can see. But some things that we can imagine conceptually or build conceptually in that graphical language might be different in our programming language, because essentially in that graphical language and UML as well, it is not fully, say so, a generalization of all possible object-oriented languages. Nor this notation theme doc, theme UML is a generalization of all possible aspect-oriented programming languages. That would be a lie to say so. So actually, it is some kind of generalization in some ways, but actually forces us to think in a different way than we implement things. And here we will see that this is the case as well. So we have this alarm class, looks like a normal class. Of course, I needed to implement some things. I needed to put some method bodies there in order just just the necessary parts in order to make this work. I have a toString method there just to make the information on whether the sensor is active easier to get. Then we have this security system is actually consisting mainly of the main method, but actually there's nothing else there. The security system class, I mean. So this is not the whole theme, the security system theme. The security system class actually here it actually has. It should have had that shutdown method there. Okay, we'll see whether I mixed it up a little bit. But essentially, we have here all the alarms defined, and each alarm is defined in a different way. So we need to have a look at this constructor. So the ID is just in order to distinguish between the alarms. Boolean special sensor is important information to us. So is this alarm connected to a special sensor? So we actually I need the security system again. wake up. Okay, so there is alarm 1 which is not, and alarm 2 which is, and alarm 3 actually it is or it is not. What is the default value for Boolean in Java? False. Maybe we should have introduced this explicitly in order not just to puzzle people, but I didn't do so. So let's do this. I don't know why I left this like this. So we have two sensors which are not special, connected to special, two alarms which are not connected to special sensors, and one of them is connected. And I would like to implement this theme that we had there. It might look like this. I don't know. So this is our, just for the moment ignore that this is an abstract aspect. I will explain this shortly, but let's look for what we understand for now. We need to block some operations. These operation calls are captured by point cut call operations. We cannot say much more about these operations at the moment because they will come out from the outside world. So for now, we just say that that's a special point cut which is not really defined for now. In this theme, it looks pretty much defined. That point cut. That's an operation call that we capture and everything. But here in aspect J, there is no way of doing this. We can just say that that's a point cut, but we are not defining this point cut yet. We will delay or postpone this to a more specific aspect. And by this, we are actually defining a point cut that is not complete, which is abstract. So there is a notion of an abstract point cut in aspect J. So this is something that we did not use before, or haven't used before. If something is incomplete in a class, if you have an abstract method in a class in Java, your class also becomes abstract. So it's the same with aspects. So our aspect, conditionally skip operations, that's the name of our aspect, becomes also an abstract aspect. Because something is missing there. And what is missing? The point cut body. There is the name of the point cut, and there are its arguments, which we will deal with. Because we deal with this operation class. We must deal with this operation class because we will need to execute this condition method upon it. And speaking of the condition method and the operation class, we actually don't have these elements as well, or neither. We are thinking we have a very narrow world. There's just our aspect there. So we are mocking things that we don't have inside of our aspects. So we assume somebody will get us what we need, yeah, by this binding relationship. But for now, we don't have these elements, and we have to mock up them. So we have this interface in order to represent our operation class. It's a strange name for the interface, you must admit. An operation class, but it's not. It's an interface because I could have used an abstract class, but it's better to use an interface because, as you know, in Java you might have as many as you want to implement relationships, but only one extends relationship. So, in order not to block our classes, which we will see that this is not just an interface floating in the air somewhere, but it needs to be connected to real classes. So for now, it's an interface, and and there we can have this operation condition, which we need to consult on whether to proceed or not. To proceed or not. So this if you compare this to this sequence diagram, looks pretty much the same or analogical. What we don't have is this operation there. We have this condition, but the operation we don't need it actually because we are letting this through this proceed expression. Yeah.
May I ask the condition it's reserved to name or a method, because I tried to change the names like on all of the places and the program didn't work. So because first I thought that the condition is like something how you name the method.
Yes, it is.
Like,
it's not a reserved root in Java.
Because I'm kind of wondering then why doesn't it work if I change if I change a condition to something else like on both of those places.
Maybe there are some other places. Did you change the name of the method all over the program? There are 4 files there.
Yes, I know I have them.
Okay, let's have a look at how this aspect is put into function. Maybe the answer will be there. So let's leave this operation. And why we don't include this operation, and so to mimic the design completely, why this cannot be done, I will explain this in this concrete aspect. This concrete aspect is an extension of our previously defined abstract aspect. So now we have to bind the things there. So all the while this abstract aspect is kept oblivious, it doesn't know about the rest of the program. In this concrete aspect, we must feed that knowledge into it. Yeah? So, first thing is that actually we reveal to this aspect that our operation class is actually our alarm class. We do this by enforcing or enforcing the implementation of the operation class interface by the alarm class. This is an aspect-oriented construct called declare parents. One of those so-called intertype declarations. Intertype declarations are an element in aspect. You can introduce some other things. We will see that later. So this is not the this is not the last aspect-oriented example that we will aspect example that we will deal with. but one of the most important of those intertype declaration constructs is declare parents. It enables you to make one type inherit from another type, both extends and implements. Right. So here, when you enforce something to implement an interface, it must implement the methods prescribed by that interface. It would be an error if we would not do that. So now we need to introduce, so this is a condition method introduced into the alarm class, which does nothing but just stands for the has special sensor method. So it just calls the method that is already there. We would like to bind this condition to has special sensor. So here it is done like this, but in aspect J we need to use its ways of interconnected methods, which are actually bound to deeper heritage of this language, which is object-oriented and which is Java. So we need to use interfaces and interface method implementation in order to achieve this. Now we can define our point cut in this concrete aspect, because we know already that what our operation class is. And that we need to track this turn off method. You might try to do this in this way here. It's just introduced as a comment, but it actually won't work. And so the same, you might be tempted to use the same mechanism as here. But the problem is that when you have a look at your security system, there are no calls to the operation, so-called operation method. There are calls only to turn off method. Turn on and turn off. So first we set up the alarms, then we turn them on. No, here we turn them on, and then we show whether they are working or not. Then we turn them off. So if we would exclude the aspects, this would look like this. And if we exclude the other one, well, if we run this security system, now it will probably show that all the alarms are turned off. Maybe there's something. So the errors are actually in this aspect when we have to change something like there, but it is not being compiled now. So our alarms are first turned on and then turned off. Okay, so all of them, and we want to exclude this one, number 2, which is connected to the special sensor, as you see. So I will bring back our aspects there. So red or not include exclude, but this is better. Oh. I'm confused a little bit, but there's exclude from the build path and then include and add to the build path. So nevertheless, this seems to be now working, or all the things that we need are there. So if we take a look once more at this aspect, I think there's nothing there. This would be just another way to deal with the thing. If we could rely on finding the operation calls, but we cannot. What might be confusing here for you is that I'm using this plus sign there. It means look for not just for lexically for the method names in the operation class, but also in the inheritance hierarchy. So all those methods that actually override the turn-off method, say so, or actually provide a new version of this method, are considered as well. If I would omit this plus sign, there will be nothing found. You can try it yourself. So now maybe this is the place that you actually could not change the method name here, condition.
Yeah, well, I found the other place, like I don't know how I missed it, now it makes sense.
Yeah, okay.
So
it works.
yeah.
So we can check this up. We will omit turning off this alarm. So it works as expected. The logic is simple, but the technical details might be not so clear. So check this program compared to design yourself. So we will deal with this in the next lab, of course. So now check the time. Enough time. Fairly quickly, we will complicate this a little bit more. So actually, we are happy, we managed to filter out this one alarm, or several alarms we might introduce that are connected to special sensor. But the requirement itself, this is the binding display once more. Maybe I should have used this to actually explain what we did. What we did in aspect J is there in this point cut, but we actually are filtering out only non-special, all the non-special sensors. But what we want to do, according to the requirement, is to turn off only the alarms that are placed in buildings. And this is our requirement, just to recall it. So we need to follow the alarms from the buildings, from the building class, and then decide which are going to be turned off. Something like this. I'm going to make it bigger. So this binding, we don't need this binding now, at the moment. We don't need this class as well. So we need this sequence diagram. We need to see this sequence diagram got really complicated suddenly, because we are not following. Maybe it would be simpler if we would consider this to be or reveal that this will be a building, this will be our room, and then there will be an alarm. So building, room, alarm. Just treat this main object as building, this as a room, and this as an alarm. Actually, this operation class, we know already this will be bound to the alarm class or an alarm object, and this is what we already saw. Yeah, so this is the same. This remains the same. Okay, at least something to rely upon, something that we know already. What's the all other stuff? So we actually are following the overall control flow. We are following the overall control flow. It goes from shutdown operation on building. So we are shutting down the building. Then we are shutting down all its rooms in a loop. And the rooms have their sensors. We are shutting down all their sensors, and only there we want to capture this operation and block it. So we must draw the overall control flow. And now the binding, of course, is just what I said. So building, room, and operation class, and operation class twice because we need both operations to be considered turn off and condition. So the same thing that we had before. And so the parameters are just as you would expect. I'm not explaining the peculiarities, so the syntax, why there are these bracket special and so on. It's not that important. It's important to manage somehow mapping between those parameters. So if you have some 4 parameters there, you probably would need to introduce, or you must introduce four substitutes from this class or theme that is, or from the classes that are included in this security system theme. And you may notice that this is our security system theme. This is an overall theme that already includes composed alarms. And what was that theme before? That we had the alarms and shut down the system. Shut down the system. So these two are already composed there, and we are adding to this theme another theme. So the point cut that would correspond to this might look like this. We are capturing the context a little bit, so the target, it's like this, but actually this is the target of our call, not the object that is going to be executed. We are capturing, the most important part is that we are capturing these turn-off methods, and we are capturing those turn-off methods within this shutdown method. Okay? Maybe it's not actually quite okay already. Take a look at this. It was my attempt to say that in this case we could deal with this in a more simpler manner. But I don't think actually this would work there either, because we have shut down there on building. And within code of shutdown, we have only lexical contents of that method. Within code, point cut is something like belongs to that family of within point cut, which actually deal with only with the lexical content of elements. So here might be some lines of code that are contained in this shutdown method, and if there would be some calls to this turn off method, then it will be fine. But since we have this another level of interaction, then it is not okay, because we are much deeper with this do operation, actually, which represents our turn off method in this hierarchy than in this control flow than on the first level. So this wouldn't work. Anyway, even if in this case, it would work if we would have only one level. Maybe we could play a little bit with within code and within code. I'm not sure. But what we can do for sure is to use this kind of boycott. We control flow. But the consequence is that by using this control flow point cut, we are ignoring all the levels of interaction, so we are not mentioning them. So it's like that start this, follow this the beginning of the control flow, and whenever whatever is between these two lifelines, no matter how many other lifelines are there, you will capture your operation, or actually turn off operation. Yeah. So when we think of that, actually maybe we don't want to have these levels of interaction expressed not even in our design. If that would be the case, we might consider something like this. Something like this, an indirect call to the operation. This indirect call to the operation means that no matter how many levels of interaction are there, consider these calls from whichever lifeline it comes, either from this one or whatever. Consider this to be the relevant call, and then apply this aspect to it, to say so. So I don't have the overall implementation to show you now, but the key to this implementation is this point cut. Okay? So capture these things in this control flow of the building shutdown, which will be bound there. Yeah, this building shutdown is actually there. Yeah?
Yes, I know it was explained, I heard it, but I'm not sure I understand it. Like, why is there the plus sign after the void operation class? Plus sign, so turn off. Like, I tried the example without the plus sign and it didn't work, and I'm not quite sure why.
Yes, it is there because you don't actually, when you have a look at your security system class,
Yes.
there are turn on and turn off methods. There is no operation there. Yeah, so you are not using this exact name to refer to the operation that you want to capture here. Oh no, you are asking this. Sorry, about the plus sign. Plus sign. If you would turn off this plus sign, you will capture only the calls to the turn off operation from the objects of the operation class.
But so if the alarms would call on itself turn off, or
if you would have you would have to have something like this in security system. You would have to define your alarms
method or
as operation class, and maybe even this. You need to. You can say no operation class because it's an interface. And once you would change all this to operation class, because operation class is an interface. Operation class is an interface that you actually enforce implementation of here. And that point cut without plus would look only for return of methods called upon references to objects defined as operation class. If you put plus sign, then it's all over the inheritance hierarchy.
Okay, now I get it.
Yeah. Okay.
Thank you.
So that's the way. And I don't know what actually else needs to be done here to make this work. I'm not sure now.
So the plus sign in this case is
Yeah.
used like it's a new program that you should look like further, like
Yes,
up.
Consider all the overridden implementations.
Okay.
Also, not just the original one, but all the overridden implementations.
And is the aspect thing or a Java thing?
That's actually a Java.
Yeah, that's what I thought.
Yeah, that's Java thing. And actually, it is transferred into Aspect.J because Aspect.J also has to deal with these things.
Okay, now it makes sense.
It's a Java heritage. Just a small addition to this notation. Once we had this indirect relationship here, we might think of how could we graphically model point cuts. We will not deal extensively with this notation, but allow me just 2 or 3 minutes just to indicate some possibilities for this. This has nothing to do with the relationships for now, but we could specify in a graphic format a quest for classes like this. So bring me all the classes that, whose name begins with my, that have these attributes, and so on. I'm using extensively regular expressions there. We might introduce some logical operators there, so I don't want classes with integers, for example. It won't take long. Alright? So we are getting to relationship. The relationship, this is more interesting, and this is what I wanted to show you. Bring me all the places where there is a such configuration like this. I might be very specific in names, but I might be relaxed in relationships. So this inheritance hierarchy might be as deep as it is. This will be captured. Okay. So we might imagine such a language for querying models, getting specific class or object configurations. Yeah. It might look like this even in sequence diagrams. Bring me all of these running configurations, relationships between objects. So an object A calls through all the control flow that there is. Finally, this method, whose name starts with mine, and so on. So this looks more like our point cut. These previous things might be more structural point cuts. If you would like to introduce some further structure into these classes or so. So we might actually like, once we create our point cut, to say what element of that point cut would need to be affected somehow or exposed. So we would put the whole thing into some kind of a block which actually this captures objects of my class, and this is indicated by that question mark there. So this is actually our object that is captured, and it captures all its operations, and this is it. So once we do this, we could rely on this as a graphical point cut. So that there's an additional language like this, which is not, of course, there was a tool some time ago, but I'm not sure whether there's anything like this specifically for aspect-oriented purposes available, but we can think of it conceptually. So in our case, we could apply this way of specifying point cuts like this to our system. So our security system, it's shut down, so we follow the overall control flow and capture these operations like this. So it might be a simpler way for expressing just point cuts. But what does this way of dealing with point cuts does not do is to expose the structure very much. So again, this is something, but the point cut is wrong. Right? From another example. I don't want to talk now about the combination of the two. We'll talk about this maybe in the next lecture. It's not very important. What I would like to point out are these two conclusions, to say so, to recap the lecture. We notice that aspects can be identified already in requirements, and we dealt with them extensively in design by fulfilling this condition to expressively capture the structure and behavior and to define their composition. So these things are essential if you would like to have a comprehensive approach to modeling aspects graphically. This is independent of programming language mechanisms, but as you noticed, introduces its own mechanisms and complicates things further. So it should be used when it can help. So it's not a means that will save us of the complexity of thinking of aspects or considering aspects in our programs at all times. But for communication purposes, it might be very beneficial. Any particular question? This?
I mean, just one. It's going to be quick. Like when you are hijacking some method, I noticed there is always the return type always has to be specified, so there is no way around that. Like
when we are capturing some method in aspect-J, we always need to specify
the type, not the return type. Okay, that was the question. Like,
do we need to do that?
Yeah, like, is there any way around it?
Yes, you can say that you don't care about it.
So I put asterisk. Okay. Okay. That's already.
Anything else? Okay, try also this example, please, related to lecture 4, and we can talk about it next time. Thank you for your attention. See you next time. Next time we'll start again with the lab. I think it's better. The lab and then the lecture.